Hello friends, welcome to TechCube Gate classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Government Engineering College Bilaspur, Chhattisgarh. And in this video lecture series, I am dealing with Signals and Systems subject. Today it is the 40th lecture and we are starting with module number 7. This will be the last module of this whole series of Signals and System, in which till now, till module 6, we have completed classification of signals and systems, LTI systems, Fourier series for Fourier series for periodic signals, Fourier transform for aperiodic signals, Laplace transform and Z transform. These 6 chapters we have completed in 6 modules, and then now we are starting with the module 7, that is Dtft and Dft and group delay, phase delay. All miscellaneous portions will cover up here only. So I hope you must be solving previous year gate questions and engineering service objective questions also, and engineering service mains questions also. Maybe you must be finding some questions difficulty, so you can post that questions in the Telegram group which we have formed, and you can find the link in the description box also. Almost around more than 1,000 of students have joined that forum Telegram group, and continuously they are posting the questions, and we are posting the solutions also. Or if at all you are feeling any doubt in any of the video lecture, you can post there. We are ready to solve it, and we are ready to take feedback from you. So if at all you are finding informative, this type of video lecture is informative, and you are getting benefit from it, so kindly I request you to kindly put that in words in the comment section also, or in the Telegram group also, so that we can understand that what is going good and what is going bad. If it is bad also, you can post it so that we can get the feedback from it. Okay, so this initiative is a no take no gain initiative. TechCube Gate classes. No take means we are not charging any single amount of money from students. It is free, 100% free of cost for students. And no gain means we are not gaining any single money from this initiative. Even if circumstances comes, we will put money from our pocket also, but we won't get any money from this. Okay, so this is initiative is no take no gain. So if you find it benefit, so kindly share with the numerous student which you are in contact with, so that it can go to the last person of the country, so who actually needs it, but they are not aware of it. Okay, so let's start our session today. We'll start our module number 7, and today we'll start with the discrete time Fourier transform. So let's start discrete time Fourier transform. Okay, fine. So see, discrete time Fourier transform, what we'll do in discrete time. Actually, this is Fourier transform only, है ना? This is Fourier transform only, and Fourier transform we have already studied earlier, है ना? We have studied earlier Fourier transform, but we have studied for continuous time Fourier transform. Actually, earlier what we have studied was for continuous time Fourier transform. Now we will study for discrete time Fourier transform. Okay, so we'll try to relate both by formula also and everything. So see, whenever will see CTFT, that is continuous time Fourier transform. You know na, continuous time Fourier transform. Why we used, see, I'll recall you that see, continuous time, actually the signal was in continuous time domain. Okay, continuous time domain, the signal was in continuous time domain, and okay, we wanted, and signal was periodic or aperiodic. So I told you that Fourier transform is calculated, or it is used for only a periodic signal. Fourier transform, see, Fourier series are for periodic signal, Fourier transform are for aperiodic signal. So I'll write here that Fourier continuous time Fourier transform aperiodic signals. Okay, so CTFT why we used, because we were having the signals is in continuous time domain and it was aperiodic. Okay, and now what we done is, see, if you see continuous time Fourier transform in frequency domain, if you see it is in time domain, it is in frequency domain, what will happen? um, See, let's suppose we'll take one example. This is one example. This is one example. It is e to the power minus 80 u of t. है ना? It is e to the power minus 80 ut. Is it in continuous time domain? You'll say yes, sir. It is in continuous time domain. Is it periodic or aperiodic? Then you will tell, sir, it is the value is tending to zero as t is tending to infinite. So it is a aperiodic signal. So whenever we will take Fourier transform, if you could remember the form Fourier transform, we got that a plus j omega, and if we will plot this type of 1 by a plus j omega, its magnitude response was like this, है ना? Was like this. So this was in frequency. So tell me that whenever a continuous time domain signal and aperiodic signal is transformed in frequency domain, what we got? We got it is in continuous. So we can say that it is in continuous time domain. Continuous. Okay, signal is continuous. Okay, continuous time not. It is in frequency. So continuous in frequency domain. Okay. And is it periodic or aperiodic, sir? It is a aperiodic type signal. It is not periodic. So we can say that it is a aperiodic type of signal. Aperiodic type of signal. The same we'll do with the this. If you have understood, the same we'll do with the discrete time Fourier transform, Dtft. Dtft. What we are now going to see for Dtft, signal is discrete or discrete or continuous in time domain, so it is given discrete. So for discrete time signal, discrete time, and signal for which type of signal will take, periodic or aperiodic? See, for Dtft, Fourier transform is always taken for aperiodic signal, so we'll write here as aperiodic signal. Okay. So see, what is the difference between CTFT and Dtft? It was in continuous time domain but aperiodic signal. It is discrete time domain signal but aperiodic. So signal will be aperiodic only, and whenever signal is aperiodic, we will take Fourier transform only. But the thing is, maybe signal can be in continuous time domain, maybe signal can be in discrete time domain. It can be anywhere. Okay. So now I will tell you. See, when for by using Dtft, we can transform this type of signal, discrete time and aperiodic signal, into frequency domain. We can change it into the frequency domain. Okay. So what we'll get? What we'll get? See, here I will write it, but after solving some of the question, you can understand this, that here we will get as continuous and periodic signals. Okay, continuous and periodic. Just of all, just as of now, you just write it down, but after solving one or two questions, you can definitely understand that why I have given you. So now, as of now, just keep this value, keep this whatever is visible in screen, just you remember it. CTFT though, okay, you can understand because I have taught you. DTFT now I'll teach you, then you can understand this line, that how it is transforming to continuous and periodic signal. So see, let's go on and we'll start our DTFT chapter. So for CTFT, what was happening, if you transform f of t, है ना, f of t, if you will take Fourier transform, okay, Fourier transform, what you will get? You will get f of omega, definitely f of omega. But if the signal is in discrete time and you will take Fourier transform, so what you will get? f of omega only. Okay, f of omega only. So it will be in continuous time domain only, na? So a continuous frequency domain only. So this you should remember, this line you should remember, that f of t Fourier transform is f of omega, f of n Fourier transform is f of omega. Achha, for DTFT I have told you in Z transform also, so you can recall from there also. So see, f of omega, what will be the formula for f of omega? See, ultimately for continuous time domain, f of omega was nothing but minus infinite to infinite f of t can be written into e to the minus j omega t into dt. So f of omega used to come very easy. This is called as CTFT. Okay. Now for discrete time domain, what will happen? F of omega will get, but here for integration we will have summation. So we'll get n is equal to minus infinite, so infinite f of n will be there, and here e to the power minus j omega n will be there. Okay, and this formula is used for Dtft. Okay, see, the way of expression can be different. It is can be represented as f of omega, or you can represent f of omega as f of j omega also, f of e to the power j omega also. You can write e to the power j omega also. You can also write as f of ohm, because see, ohm, you can write e to the power j omega. Okay, can be written as e to the power j omega. Okay. Oh, no, sorry. Only omega, omega. Ohm can be written as omega. So you can write f of omega can be written as f of ohm. You can also write as f of j ohm, or you can also write as f of e to the power j ohm. So like this type of expression, you can explain this Dtft value, Dtft. Okay, so if you find terminology like this in question paper, if you find f of j ohm, so you should understand that we are taking Dtft only. Okay, so see, I have told you the formula how to calculate the Dtft value. So now we'll see one question and we'll try to understand how while solving question we'll use the Dtft formula. So one question was given to you. Let's suppose f of n is nothing but a to the power n u of n is given. A to the power n u of n, and mod a is given less than 1. है ना? Now you need to find the Dtft. Dtft of the signal. Okay, so how we'll do it? See, the formula for calculating Dtft is f of omega is there. है ना? Will n is equal to minus infinite to infinite is there. A to the power n u of n is there. Okay. Now what will happen? See, values are there from here to here. Okay, and we can put e to the minus j omega n is also there. Okay, so u of n means it will start from n is equal to 0 to infinite. N is equal to 0 to infinite. A to the power n e to the power minus j omega n. So we can take common as e to the power a e to the power minus j omega to the power n. This we can put. Okay, so here if you'll expand it, you'll get 1 plus a e to the power minus j omega plus a e to the power minus j omega square, and so on, it will go on. So GP series will get first term by 1 first term by 1 minus common difference. Common difference is a e to the power minus j omega. So this is the answer for Dtft for that. And see, here see what happened. This series will converge when this a e to the power minus j omega mod value is less than 1. Then only this series will converge. Otherwise this series will be infinite value. So ultimately you can say that mod of e to the power minus j omega is less than 1. Okay, as in the question mod a was less than 1, so ultimately mod of e to minus j omega is less than 1. Okay, so this will be the f of omega. This answer will be f of omega value. Okay, see, I told you when we were solving z transform, if you have seen a to the power n u of n, z transform, if you take z transform, then what you will get? 1 by 1 minus a z inverse. Okay, and I told you for C, what I say, for this mod z was greater than a. Okay, mod z is greater than a, and your a is less than 1. Okay, this is unit circle, and a is less than 1 and mod z is greater than a. So ultimately it will include the unit circle also. So ultimately this z transform will be convergent for unit circle also. Therefore for finding Dtft direct formula we can also apply that z can be written as e to the power j omega. So it value can be 1 by 1 minus a e to the power j omega to the power minus 1, which is equivalent to this. So for solving DTFT, I have told you from Z transform also you can calculate, and this formula is also there to calculate the DTFT. See, while studying the Fourier transform also, we have come across some of the signals which are not absolutely integrable. Their Fourier transform could not be calculated. So like that, same as in this discrete time Fourier transform also, some signals like see, we have talked about a to the power n u of n. If I'll talk 2 to the power n u of n, then its Fourier transform can be calculated. You will tell, sir, 1 by 1 minus 2 e to the power minus j omega will be the discrete time Fourier transform like that of a to the power n u of n. But this is wrong. This is wrong, because here mod of a value is less than 1. Then only we have taken the discrete time Fourier transform. But here mod of a value is greater than 1. So don't choose this option in the question. Okay, this may be in the option, but you need to understand that this value is greater than 1. So 2 to the power n of un means that it will be go on it for this value will go on like this. Okay, 2 to the power n un means n 1, n2, n is equal to 3, n is equal to 4. It will be like this value. It will go on increasing. So it is not absolutely summable, and if it is not absolutely summable, its DTFT cannot be found, cannot be calculated, but if this will be half to the power n u of n, then definitely it can be calculated as 1 by 1 minus half e to the power minus j omega. So this you should remember. Okay. So I think from this question, from C till now what we have talked about, this formula you have studied. From this question you have understood that how to calculate DTFT, how to calculate DTFT value, and you have seen, and for which DTFT cannot be calculated, that also you have seen. Okay, now we'll see some of the standard signals DTFT, like gate pulse is there, triangular pulse is there. So we'll find the discrete time Fourier transform for signal like, see, this was minus t by 2 to t by 2, and if you could remember a, this signal Fourier transform was, if you can remember, a into t sampling of omega into width by 2, width by 2 was there. Now we'll take same type of signal in discrete time, like gate pulse is there. Okay, but we'll take like this value. Okay, and this value will be there. Let's suppose this is from minus n to plus n values there. Okay, and magnitude is 1 only. Now we need to calculate the Fourier transform for this type of signal, so DTFT means Fourier transform only we need to calculate. So what will be our procedure? What will be the approach for us? So see, formula is the main approach is f of omega, n is equal to minus, from minus n to plus n will take. Okay, and value is 1 only, e to the power minus j omega n value will be there. Okay, now see we are integrating from minus n to n, means from the left portion to the right portion, or we can take from one portion only. So making the lower limit 0 to make to start with 0 to the power 2n like this. So to make lower limit 0, okay, to make lower limit 0, what we'll get, see, making this lower limit 0 means n plus n. Okay, this will come here, n plus n will be equal to m, which will take as 0 from starting. So here we can put the values like this. It will start as f of omega will be called as m is equal to 0. It will start, and for m it will be For n it will be, see, this is n is equal to minus n, n is equal to n, okay, and n is nothing but m minus n, so m minus n is equal to n, so m is equal to 2n है ना. So we can write here m is equal to 0 to m is equal to 2n है ना, and your value will be e to the power minus j omega, e to the power minus j omega n was there, and n is nothing but m minus n, so you can write m minus n value है ना. Now this value can be expanded, like, see, e to the power minus j omega n can be outside because that is constant, so e to the power j omega n can be outside, and now summation of m is equal to 0 to 2n e to the power minus j omega m will be there, okay. And then you can expand it as e to the power j omega n value will be there. This value will be start from 1, okay, e to the power minus j omega m value is 1, okay, and then it will go on e to the power minus j 2 omega, and then it will go on till e to the power minus j omega and 2n values है ना, 2n, okay. So this series will go on like this. Now see, e to the power j omega n is there, okay. This series is there, okay. This series is a finite GP series, so we'll write as 1 minus a to the power, a is nothing but e to the power minus j omega n plus 1 है ना, n is nothing but here 2n is there, ultimately final value, so 2n plus 1 value is there, and 1 minus a value will be there, 1 minus e to the power minus j omega value, okay. This value can be solved, this can be solved as e to the power j omega n value will be there. You can take common as e to the power minus j omega 2n plus 1 by 2 also you can take common, and then you will have the formula like e to the power j omega 2n plus 1 by 2 will be there, and you will have minus sign is there, so minus you can take minus e to the power minus j omega 2n plus 1 by 2, okay, like this. The same happens with the downside also, e to the power minus j omega by 2 can be taken as common, so e to the power j omega by 2 and minus e to the power minus j omega by 2. This in mathematics you have done, maybe you must have done earlier, you have. So here comes that we can cancel out many terms na. After cancelling many terms, what you will get, sine of omega into n plus 1 by 2, okay, and in downside what you will get, sine of omega into omega into 1 by 2, okay. So this is the final answer, what is it? It is f of omega value is there, and see what you are about to calculate, the Fourier transform for this type of discrete time of signal. The Fourier transform what we got is sine omega n plus 1 by 2 by sine omega into 1 by 2. It is, you can see that it is a ratio of sine signals, okay. So I think you have understood this. Now we'll see again one more question. We'll try to solve that question. See, our triangular pulse is there, okay, maybe I'll show it with this. This is the peak, and then it is going on decreasing, okay, it is decreasing. The same with the left hand side also, okay, and it is going from let's suppose this is the value, n is equal to 0, and then 1 2 3, and then go on, let's suppose minus 1 minus 2 minus 3 and minus 4, and go on like this. So value may be this value may be, let's suppose 3 2 1, okay, 3 to 1, and it may be half or something, or let's suppose that this portion is 0 only, okay. This portion 3 2 1, and this portion is, let's suppose, 0 only, okay. Okay, so like this signal is there, this is actually triangular pulse only, this is triangular pulse. It will go on like this. Here values are there 0, no, I'll keep here 0 only. I'll keep here 0 only. So ultimately it is actually a triangular pulse. Okay, it is a triangular pulse. So what we need to calculate, it's Fourier transform. We need to calculate. How we'll calculate Fourier transform? We'll see that Fourier transform is nothing but minus infinite to infinite. F of n is there, e to the power minus j omega n is there. Just this small formula is there. Okay, so see, for you can see for minus infinite to infinite we need only these values are there. So actually f of 1 can be calculated. F of 1 we know. F of first of all, f of 0 can be calculated, because for n is equal to 0, you'll get f of 0 plus f of 1 will be there, e to the power minus j omega, plus f of 2 value will be there, e to the power minus j 2 omega. Okay, and you can, if you can see that here, f of minus 1 also there, f of minus 1 e to the power j omega is there, plus f of minus 2 value will be there, e to the power j 2 omega. So like this value is there, you can put the value. This value is at f of minus 2 is nothing but 2 value, 1 value is there. Okay, 1 value, e to the power j omega j 2 omega, plus f of minus 1 value. F of minus 1 is nothing but 2 value, so 2 e to the power j omega, plus f of 0 is nothing but 3, plus f of 1 is nothing but 2 e to the power minus j omega, plus 1 e to the power minus j 2 omega, and this can be simplified as e to the power j 2 omega, e to the power minus j 2 omega. So only we need 2. It can be written as cos 2 omega. It can be written as 2 not. It can be written as 4 cos of omega plus value is 3. So this is the final answer. See, what very easy. If it is a finite if it is a finite signal is given, so just you need to put the formula, and the values are there, and just its answer is in your can be calculated within a minute. Within a minute your discrete time Fourier transform can be calculated. Okay, now after understanding this two standard signals, how we can calculate Dtft is very easy. So you can calculate for sawtooth pulse also. Whatever signal is there for discrete time domain, you can calculate Dtft by formula. It's very easy. Now we'll see some concept. We'll try to understand some concept that, see, uh, whenever a signal, let's suppose a to the power n u of n was there, its Fourier transform was what, 1 by 1 minus a e to the power minus j omega when mod of a is less than 1. This was there. Okay, see, if you put instead of omega, if you'll put omega plus 2 pi k, okay, some frequency is shifted by 2 pi k. Okay, so what will happen, 1 minus e to the power minus j omega is replaced by omega 2 pi k, 2 pi k. Okay, so how we can write here as 1 by 1 minus a e to the power minus j omega is there only, and now what is there, you can write e to the power minus j 2 pi k is also there now. As you know, e to the power minus j 2 pi k can be written as cos of 2 pi minus j sine of 2 pi, e to the power minus j 2 pi, e to the power minus j 2 pi can be written as like this. Cos 2 pi, see, cos starts from here, cos pi by 2 pi, 3 pi by 2 and 2 pi, so it will be 1 only, and this value will be sine of 2 pi will be sine of 2 pi 0 pi by 2 pi, 3 pi by 2 2 pi, so value will be 0 only, so this is cancelled. So ultimately e to the power minus j 2 pi is nothing but 1, and 1 to the power k is nothing but 1 only. So ultimately this again can be written as 1 minus a e to the power minus j omega. So see, earlier it was 1 by 1 minus e to the power minus j omega. Again it came like this only, means there is nothing change when omega is replaced by omega plus 2 pi k. This signifies that the things are repeating after 2 pi k. The things are repeating after 2 pi means the periodic 2 pi k only, some multiple of 2 pi. So the frequency is periodic with period 2 pi k. So ultimately what the conclusion we got is DTFT, है ना? Because see this where we are doing, in this we have done like this, है ना? What is this? This is DTFT of this signal, है ना? So what I am telling you that DTFT of a signal, DTFT of a signal, let's suppose f of n is the signal, DTFT of a signal is always, है ना? DTFT of a signal is always continuous. This is continuous, which we have seen this. It is coming in omega value, na? Omega value is coming. Omega is continuous only, so it is in continuous quantity. It is in continuous quantity, but it is periodic because as we are changing the frequency by 2 pi k, this expression is the same. So it is, but it is periodic. It is periodic with period 2 pi. Okay, this you should remember, and that's why I was telling you in the starting of the session. I was telling you, I will tell you afterward like this. See, discrete time Fourier transform, how a discrete time signal and a periodic signal is transforming into, see, continuous and periodic. Now only I told you that in DTFT, in frequency domain, the signal is the signal omega can be represent. Omega is there means it is continuous. N into omega will be there. Something means n will be there, and omega will be replaced by 2 pi to the power by n, and then it can be called as discrete. But here omega is there. Omega is a continuous thing, so continuous is there, and it is repeating after every 2 pi. That is why it is periodic. So now this expression you can understand what I told you, because this both expression is very important, because many times one liner questions comes from this topic only, but you should understand the concept. That's why I am focusing on this portion. So DTFT of a signal f of n is a continuous quantity, but it is periodic with period 2 pi. It means that let's suppose, see, f of t was there. Okay, f of t was there. When we have taken its Fourier transform, what we got? We got, let's suppose we got like this. Plus omega m to minus omega m. This some signal is there. Maybe its magnitude is decreasing with respect to frequency. This is a dummy. If I am saying you, this is f of omega. I am letting you that if f of t was a signal, its Fourier transform is f of omega. This one, then f of n Fourier transform whenever we will take f of n Fourier transform whenever we will take, what you will get? You will get this value, so you will get, है ना? This value you will get minus omega m and omega m, but again you will get the same thing. Again you will get the same thing. Again you will get the same thing. Again you will get the same thing, and this value, है ना? This value 0. This value is 2 pi. So after every thing that see, what will be this value? What will be if I will say this value should be what thing? Okay, so see, see, every value is same after 2 pi. So this value is minus omega m. So ultimately again this value came. This value will be obviously after 2 pi the same value will come. So this value can be written as 2 pi minus omega m, means minus omega m will be there plus 2 pi we have done. So we'll get the same. Again this value will come. Okay, again this value will come. So in this value we'll add 2 pi more, and then you'll get this value, means this value will be 4 pi minus omega m, like this. So see, Anyway, any signal uh, in time domain, if you take Fourier transform, you will get some to frequency na some, you will represent that signal in some frequency. I have represented by omega m maximum frequency, and this is in the left domain. Like the same thing, if the signal is in discrete time domain and we are taking Fourier transform, we will get the signal in frequency domain, but we will get repetition of that signal after every 2 pi period. So can you say that this omega m, this omega m should always be less than this 2 pi by minus omega m? Bhaiya, this value should always be less than this value only na. So omega m should be less than, or equal to 2 pi minus omega m. This cannot be greater than, because if this value will be greater than this value, then there will be aliasing effect, overlapping will be there, that is called aliasing. So omega m at max, it should be equal to 2 pi by minus omega m, or it should be less than. So you can clearly mention that it will be 2 omega m should be less than equal to 2 pi, and therefore omega n should be equal, less than or equal to pi, है ना? So this condition, when it will come, when we need to avoid the aliasing effect. If you want to avoid, then maximum frequency of this signal should be less than or equal to pi. Okay, so now you must have understood that why I was talking that in frequency domain it will be continuous and periodic, because see, by seeing this representation, you can understand that it will be continuous also and periodic also. So remember that whenever our signals will be in taken Fourier transform from discrete time, so it will be continuous and it will be periodic with period of 2 pi, with period of 2 pi. This you should remember. And to avoid aliasing, the maximum frequency should be less than or equal to pi. Okay, so see, now we'll talk about inverse Dtft. Inverse Dtft, how we can calculate inverse Dtft, means inverse Fourier transform. So see, as you know that in continuous time domain, how we used to do f of t. If you wanted f of t, you should do 1 by 2 pi minus infinite to infinite, f of omega will be there, and e to the power j omega t d omega you used to, है ना? This was there for continuous time Fourier transform. For our discrete time domain, we will get f of n only, and here we will take 1 by 2 pi, 1 by 2 pi value will be there, and then we will get minus pi to pi for a one period will do, because it's see, if any signal is periodic, means same value will be going on, so it's better to calculate for one complete period. So we'll do minus pi to pi, है ना? F of omega will be there, and e to the power j omega n will be there, d of omega will be there. See, you must be thinking that, sir, why we have not used summation sign? Why will use summation sign? F of omega is continuous or discrete? F of omega is continuous. So wherever we are taking continuous, so we'll take this value only, है? But f of n to f of omega, f of n was discrete. That is why we have taken the summation value in the Dtft formula. In Dtft formula, we have seen the summation value, है? So whichever may be discrete, we'll take the summation, and whichever is continuous, we'll take integration sign. Okay. So let's calculate some of the Dtft value. So we'll see question. Let's see some question that find the inverse Dtft of f of omega is there is equal to delta omega. See, delta omega is there in the frequency domain. Now see, whenever you have been asked question inverse Dtft, your mind should click inverse Dtft, means it will be continuous and periodic also, है ना? So this signal is continuous and periodic also. It means that f of omega you can either plot like this, delta of omega, or or you can also represent as delta omega, है ना, delta omega is there. Now we can also it write as delta omega minus 2 pi k. So like this, every after 2 pi period it will be like this only, it will be like this only. So maybe it is zero value, t, 0, omega is equal to 0, it will be 2 pi, it will be 4 pi, and so on, it will go on like this. So your question, by seeing question, first of all your mind should clear that what I am talking about, this is delta omega, this can be written like this also, okay, no problem with that. So for calculating inverse DTFT, what is the formula? F of n you want. So 1 by 2 pi will be there only, 1 by 2 pi. For one time period we'll see minus pi to pi will see, and delta omega will see e to the power j omega n d omega. So ultimately answer will come 1 by 2 pi, like that of Fourier transform also. So we can say that delta omega Idtft है ना, will be 1 by 2 pi only. So can you tell that what will be the see DTFT of 1? DTFT, see, if you see like this, so you'll get 2 pi delta omega, 2 pi delta omega. So or you may say 2 pi delta omega Idtft is 1, or you can say that 1 DTFT is 2 pi delta omega. So this, or you can also say that 1 DTFT can be written as 2 pi delta omega minus 2 pi k, and what is there, summation value will there, k is equal to minus infinite to infinite, है ना, because many are there. So ultimately you can also say this value and this value, this is the answer, because in answer you can find this also and you can find this also. So you should understand that whenever you will find this value, when you have been asked Idtft, है ना, because in DTFT only, in the frequency domain only, the signals are continuous and periodic. We'll see one more question, we'll try to understand more. So you need to find the Idtft of f of omega is there. F of omega is nothing but delta omega minus omega naught is there. See, f of omega is there, delta omega minus omega naught, and you need to find Idtft. Idtft is there, it means that you have to find, means it is a DTFT expression, and DTFT is always periodic with period 2 pi, है ना. So this expression f of omega can also be written as k is equal to minus infinite to infinite, because k value will be changing, okay. Delta omega minus omega naught is there, but it can be 2 pi k also, है ना. After every 2 pi k the value will be same only. So can be written as like this, okay. So f of omega formula will be 1 by 2 pi minus pi to pi, and what is the expression, delta omega minus omega naught e to the power j omega n value is there, है ना, and d omega, okay. So see, here we can say 1 by 2 pi e to the power j omega 0 n value will come of which value, see, delta omega minus omega naught Idtft value is 1 by 2 pi e to the power j omega 0 n, okay. So ultimately I can say that e to the power j omega 0 n DTFT value what will come, 2 pi delta omega minus omega naught will come, okay. The same expression can be written as e to the power minus j omega 0 n, can be DTFT value can be written as 2 pi delta omega plus omega naught value can be written, okay. Okay, so if you can write like this, then obviously that if I will ask you find the I will ask you find the DTFT of cos of omega naught n and sine of omega naught n. If I'll ask you, then what you'll answer, sir, if both are added and done half, है ना, half e to the power j omega 0 n plus e to the power minus j omega 0 n. Okay, what you'll get here also half will come, so pi delta omega minus omega naught plus delta omega plus omega naught will get, है ना? Okay, and if see, it is equivalent to Fourier transform only, what we have seen earlier, है ना? But what will be the difference, I will tell you. So it can be written as cos of omega naught n, cos of omega naught n, and it can also, see, this expression can also be written as, I will tell you, pi will be there only, k minus infinite to infinite value, and you can write delta omega minus omega naught minus 2 pi k, minus 2 pi k will be written as like this, and plus delta omega plus omega naught will be there minus 2 pi k value. So cos of omega naught n Dtft value is like this. Okay, the same happens with the sine of sine omega naught n. Sine of omega naught n will be 1 by 2j will be there, e to the power j omega naught n will be there, minus e to the power minus j omega naught n will be there, है ना? So here we will get pi by j value and delta omega minus omega naught minus delta omega plus omega naught value, है ना? This value will be there. So, and the same can happen here also, sine of omega naught n Dtft value will be pi by j will be there, है ना? Pi by j value will be there, k is equal to minus infinite to plus infinite, delta omega minus omega naught minus 2 pi k value will be there, and minus delta omega plus omega naught minus 2 pi k value will be there. Okay, so see, from here I think by solving this much question you have got the preliminary idea that first of all, how to calculate the Dtft signal. See, very limited questions we are doing, but main questions very limited like this. If n number of samples are there, then how we can calculate it. If limited number 2-3 samples are there, some fixed number of samples are there, how to calculate it. Then we have seen how Dtft looks like in frequency domain, and then we have seen how to calculate Idtft, and then we have seen see one delta omega, how we can calculate delta omega minus omega naught. Then we have seen how to calculate sine omega naught and cos omega naught and Dtft. So here I think something is cleared in your something should be cleared in your mind about Dtft. The same condition, see, when we were reading continuous time Fourier transform, we have seen the three conditions, like some signals are there, f of t signals are there, three type of signals are there, है ना? Three type of f of t can be happen. One, f of t can be absolutely integrable, okay. Some signals are okay, not absolutely integrable, but indeterminable, means we can say that not absolutely integrable, we can say. And some signals are absolutely tending to infinite. It is not tending to finite value, when t tending to infinite. Here this tending to 0 value when t tending to infinite, and here the values are tending to infinite value when t is tending to infinite. F of t, a signal can be three type. Either it is tending to 0 when t is tending to infinite, maybe, like, see, I will tell you with example. This type of signal represent like this type of, so e to the power minus at u of t, है ना? Like this type of signal is tending to 0 when t is tending to infinite. This is absolutely integrable signal. This type of signal is having some finite value. Let's suppose u of t is there. U of t is having some finite value when we are going t tending to infinite. Let's suppose signum t value is there, है ना? Like this type of value. And this type of signals, some type of signals are there like this, which is absolutely like r of t, which is absolutely increasing its value is tending to infinite when t is tending to infinite. So like this type of signals, we have seen that we can take Fourier transform directly. It means Dtft can also be calculated for f of t or f of n, है ना, f of t or f of n. Like this type of signals which are absolutely integrable or summable, which are absolutely summable, their Fourier transform, है ना, चाहे CTFT हो या DTFT, we can calculate very easily by the formula. Those signals f of t or f of n, its value is tending to finite value, है ना. So there we need that is here we are limitedly defined Fourier transform. So here we will take by indirect technique, we will try to find out, we will not use directly formula, and here it is not defined, and that's why I told you, like 2 to the power n u of n is there. These values are not defined. So ultimately the similarity between CTFT and DTFT I told you. So today we will close with this topic. Next topic I will try to tell you the some properties of DTFT, like time shifting property, frequency shifting property, what happens when we will multiply with n, है ना, what is convolution property, what is area property. We will solve some questions, spectral density property, time differentiation property, time integration property. So in the next lecture we'll try to finish up with the properties of the DTFT, and we'll try to close up with DTFT. Okay. Okay. So thank you so much for this lecture. If you have liked the video, then please comment in the comment box. Till then, tata, bye bye, see you, have a good day, keep solving, happy learning, Jai Hind, Jai Bharat.